Okay, for the next question, we have a reaction system. We have A plus B forming C and A plus B forming D. C's are desired products, D's are undesired products. So these reactions are in parallel. And so we can represent them by the system of differential equations. So we have the differential equations here, and then we have the constants K1, K2, and then the initial values, and we have the temperature. So we've done something like this before, but we'll still briefly go over it. Now, if you want to solve a differential equation, remember we said we always start by typing out the function. So let's say function dc dt is equal to maybe reaction, right? And then the independence before the dependent, so t comma c. Then I can now write out the expression. So I can see that maybe let me say dc1 is equal to, so 1 is going to be for A, 2 will be for B, 3 will be for C, and 4 will be for D. So the C1 is equal to minus K1 CA, all of that. But before I can express K1 and K2, before I can do this, I have to express K1 and K2. So let me come down here and get an expression for K1 and then for K2. And before I can do K1 and K2, I also need to get T, because K1 and K2 depend on T. So I'll put T is equal to 500 first, and then the expression for K1. So K1 is equal to 1.1 times 10 to the power 7 times exponential minus 9200 over T. And then K2 is 4 exponential. So K2 is equal to 4 exponential minus 2000 on T. So I have that down. So now the C1 is minus K1 times C1, so that's CA, times C2, that's CB, minus K2 times C1 to the power 0.5. Let me put this into a bracket, times C2 to the power 1.5. So I can close that, and I can now say, if I want dCB dt, I can say dC2, so 2 is for B, is equal to, the expression is very similar. Let me look at it. Okay, the expression is actually the same thing, so I can just copy this one here. Sorry. Okay. So I can copy this equation and then just paste it there. Then dC3 will be equal to, so that one is K1 times CA, which is C1, times CB, which is C2, and then dC4 is going to be equal to K2 times, is lowercase k, K2 times CA, so that's C1 to the power 0.5 times CB, that is C2 to the power 1.5. Okay, this is for the function we have. Now we want to get the expression for dC dt. That's going to be equal to my dC1, my dC2, my dC3, and then my dC4. So it's going to be equal to a vector containing all the equations we just derived. Then I can type end. Now I've ended the function. Now if I want to solve this differential equation, remember we can do something like this. So I can say t comma c, t comma c is equal to ODE 45 at the function in which is react, then comma the span. So I'm doing this for or if not even for the span, I can put my initial no, I'll need a span. So I'm coming, let's see. Expand of values for the time. I don't know if it was given in the question. If it wasn't, we use our own values. Okay, it wasn't given. So let's put in our own values for the t span. So t span is going to be equal to, let's say we're starting from 0 and we want to end at maybe 20. Right, so let's use this for a t span. So I can put the t span here, and then our initial conditions. So I'll type ice initial conditions. So for the initial conditions, CA not, that's the species CA, that was 1, is 1, B was 1, C was 0, D was 0. So these are our initial conditions. So I can put that here, T span, comma, our initial conditions. So now, before we do the plot, let me run it to make sure we don't have any errors so far. Okay, it doesn't look like there are any errors, so we can continue. So now if I want to plot the concentration profiles against the time, I can type plot t comma c. So let's look at what that will give us before we carry on. So we're going to get the concentration profiles for all the species, but the question said something a little bit more. It said that on the same graph, plot the graph of yield and selectivity of compound D with time. For the purposes of these calculations, we have the expressions here. So now let's get the expression for the yield and then the expression for the um we're getting the expression for the yield and then the expression for the for the selectivity. Right, so if I want to, let me clear the plot expression. If I want to get the yield, remember we have CC here. If I want to access CC, I'll type C into bracket colon comma 3. Right, this is going to give me CC. So C into bracket colon comma 3. That'll give me the values for CC. Right, so if I want to type that, I can say that my Y is equal to CC dot over CA naught, which was 1. Right, so for the question, CA naught was 1. Then and then the selectivity is equal to CC, because C was the third one, A was ABCD, C was the third one, over CD, so that's going to be 4. So CD plus E. So I have to define E plus E. So let me come up here and define E. So we said E is equal to 10 to the power minus 20. So I've gotten that defined. Oh, and sorry, the C here, the C is supposed to come out. It's supposed to be this way instead. So we've gotten our selectivity and our yield. Now we can go back to our plot. And the question said that we should have the there was a point here. The yield and selectivity must have different axes, different y-axis. So it means one of them should be on the, it means the concentrations will be on one axis and then the yield and selectivity will be on the other axis. So the way we can do this is we can type y axis left, right, and then say we want to plot our concentrations against our time, and then we can label. So we can see that maybe the y label here is equal to concentration in kilomole per meter cube, and then maybe our x label is time in seconds, and then we can have a legend for that part. So we can say legend, we can say CA, CB, CC, and then CD. Right, then we can now come to the next part and then type y axis right, and then we can say we want to plot. So first we want to plot the yield against time. So it is time and yield then time and selectivity. So we can label that axis. So y label, that one is going to be I think this one, let's call this one maybe yield and selectivity. I think that should be fine. So let's run it and let's see what we would get. Oh, so this is going to be our graph. Yeah, I think it's giving too many data points. Okay, let me take the legend out of the side for now, so that I can show us the axis thing first, then we'll come back to that. Realize that it's going to plot concentrations on the left side. It's going to plot yield and selectivity on the right side. The concentrations are in our blue, and then the yield and selectivity are the ones in the orange. Right, so we can do it this way. Okay, so this is just a little side and a little top up. I realized that with the previous one I made a mistake. So what I had done was that for the legend I had clamped them all together like this, right? But then they were all supposed to be separate. So CA would have its own inverted comma, CB will have its own inverted comma. And then the legend, you can put it after you specified all your axes, both the left y axis and the right y axis. So it will follow the format from top to bottom. So the first thing we plotted was CA, then CB, then CC. So we can label it that way. Then CD, then yield. That was on even another axis, but that was the next thing we plotted. Then yield and then selectivity. Right. So this is just to make a correction in terms of labeling the axis. So if we should do this, right, and we should run it this time, this is what we are going to see. And now we have everything properly done. So we have the legend as well to show us what we have. So we have CACBCC all the way to the bottom, and then we have the yield and the selectivity as well. This is just a correction. Beside that, one other correction to also make. So it sounds like these are some things you might end up overlooking if you are not careful. Realize that the S expression, right? I didn't bring a dot here. I was supposed to, right? So if I should run it this time, this is what I should be expecting instead. So the reason why I was prompted that there was an error was because, let me take the dot out and show you what I'm talking about. This is what prompted me that there was an error. Realize that from the graph here, yield and selectivity have different symbols. So one is supposed to be a straight, one is supposed to be a broken line. But then if you look at it, you are not seeing that distinction between these two. And we are seeing an extra line down here that has not been accounted for. It means something is wrong with something we've plotted, especially from the yield and selectivity part. So when I came back, I checked through and realized that the selectivity, I forgot to put a dot here. Remember, I'm dividing a range by a range of values as well. CC is a range of values, CD is a range of values, right? So I'm supposed to put the dots there. So now that I've put the dots there, if I should, oh sorry, and I think I changed this expression. Let me change it back to the original. I was trying out something. So if I should do it this time, this is what I should be expecting. So now I realize that the orange lines are different. I can now get a straight orange line and then one with the broken lines as well. Is that okay?